Good day, everyone. This is me again, Calizar, and I'm about to do our activity, our experiment 5, in our electronics engineering laboratory, or ECE20L-2. First of all, before I do my experiment, I'll make some clarifications. It says here that we need to make table 5-8, but according here, it says that, no, wait a minute. It says here that we need with the values of measured voltage gains from A8.1, A18.1, A27.1, and 3 other more questions to answer. It says here that in this table 5-8, we need to gain those answers from these questions to answers that is given by our professor. But our professor said that we don't need to make those questions to answers anymore. So we won't be doing this table 5-8. So instead, one of our assignments is table 5-7, as you can see here. It needs table 5-4, table 5-5, and table 5-6. But in our assignments, table 5-5 and table 5-6 are the only ones that are assigned. So instead of making table 5-8, I'll be doing table 5-4 in order to complete our table 5-7 assignment. So let's start. First, where is it? I need to find that table 5-4. There. So click for the new schematics. Click. Close this one. Then I'll do the circuit. F2, voltage. Click for the voltage. You need to zoom out. Capacitor here. Capacitor there. Resistor here. Resistor there. Align to C2. And a resistor here. Let me connect the wires first. So I'll connect the wires. There. Connect the wires here. Again, for the shortcut, F3 for the lines, escape, F5 for the cut, but we won't be cutting any. And let's continue. A resistor here. Another resistor down here. Put that right. Need to move F7 to move. Resistor. Another resistor here. Oh, I didn't tell you, but the shortcut for the resistor R is letter R on your keyboard. So connect the wires. Oops, I need some transistor first. F2, NPN. Zoom here a little. Oops. Oops, what did I do? I guess I won't zoom. Next is the third capacitor right here. Nope. Move that. I guess put the lines first. Wires. this here, connect this here, connect this here. Oops. Seems it ain't right. Oh well. Just I need to do this first. I don't know why, but it's just that way. Next is I connect this capacitor right here. Here's the V out. We'll name it V out later. Oops. Another resistor here. Oops. It's already there, just need to move it. Connect it. There. I'm not done. There's still a voltage here. Voltage of the VCC, the common. Need to connect it here. There. I'll rename it. We'll call this V1, V in. Let's make this a value of, look at Vance, sine. A value of 15 volts and frequency of 50 hertz. VCC. Let's get the labels first. Label net. Right here is the VB, or the voltage of the base. Next is the voltage of the common, VC. Lastly is the voltage in the emitter, VE. And we'll get the values next. We'll input the values. I guess I'll make this 100 micro and this at 200 micro, and this one is 300 micro. Resistor 1 will give you a 1K. Resistor 2 is 1.25K. 3 is 1.5K, 1.75K, and 2K. Lastly, 2.25K. Well, by the way, it says here that we need to do this as a common-emitter amplifier with load and bypass. So we won't be putting any capacitor or resistors away. So let me just run this and get the voltages in the VC, VB, VE. Oops, I forgot to assign the voltage in VCC. I'll put it in maybe 7.5. Now we'll get it. We now have a voltage in of 15 volts, if I'm not mistaken. 15 volts, V out, no, not yet. VCC and 7.5 volts, as you can see here. Now we'll get the voltage in the VC, VB, VE, and the V out. I forgot to label net the V out, so this is right here. Then let's run this thing. Letter S, DC OPNT, okay. there and click run. You might not be able to see this, but it says here that the VB has a value of 0.787436 volts. The VE has a value of negative 3.3306 065 times 10 raised to negative 5 volts. And our VC is 1.21054 volts. Our V out is negative 3.36996 volts. I guess I'll just screenshot here. How do I make this thing? Wait, just wait a second. There. You can see it now. You can see it now, right? There. That's the voltages. So our first table is done. So let me just put this away. Remove it. I'll just remove this thing. It's recording, right? It's recording. And go on for table 5.5. So I will just delete this. Or I can save it instead. Save as table 5.4. We'll get the new schematics and let's make another one. The next thing we'll do is the table 5-5, and the first thing we'll do is put a voltage in here, a capacitor here, right one, oops, I think that's correct, capacitor here, a resistance here, aligned to the R2. Is it aligned? I think so. And make another R3 and the R4 aligned with R5. Connect the wires again. As you can see, this one is identical to the last one. It's not aligned, so I'll move this R2 here. Make it down here. Escape. And we'll make a transistor F2, type NPN. We'll make a transistor here. Connect it right here. Connect it here. Oops. It's not aligned. Move by F7. The next thing we'll do is get the capacitor here and another resistor down here. And we still need another voltage here that is attached here. Oops. Disconnecting the wires, and that's about it. We put on the labels. V in. Oops, this is 15 volts. With the label of V in. This one has VCC. It's not. Oh, I forgot to connect this one. So here we connect it right there. That's what it said in the diagram. Now I get the input values of the same with table 5-4. This one is 200 micro. I think it's connected right. Wait, this is table 5. I think it's the same, right? Let's change this to none. Put the value 15. Run. It's just the same. This one is where am I? Here, 300 micro, 1K, 1.25K, 1.5K, just adding an interval of 250 ohms, 200K, I mean 2K. And this one, I won't put any values here because it says here that I should remove the connection of the output coupling capacitor C3 to the load resistor R6. So I'll need to remove this R6. I'll just make it this straight and make a short circuit here. And I forgot the V out here. That's fine, that's correct. And we need to simulate using the DCOP, PNT, and run. There you have it. Wait a minute, it's the VCC. No, I forgot the voltage in VCC. And we run again. There. Unfortunately, it has the same value. I think there's something wrong with it. I need to flip this into cut. I need to put this in. Make a line here. Another line here. And put a ground here. I think that's better. And put it in simulate. Oops, I forgot the V out. Sorry. V out. There, can run now. It's waiting to run, and there you have it. It's, I think I forgot to put on the labels. Again, put on the labels VB. Put on the label VC. Another is VE. VE right here in the node. I simulate so I can see the voltages in those nodes. It's waiting. There you have it. We have a new I'll show you the details. VC. I'll show you the details. Wait, just capture. Oops. I think that's incorrect. Where is it? Oh. Run. I put it off. I'm sorry. Here, I can show you the details. Where is it? There? Oh, it's there. There's the details. So as you can see, I put in the word file. The value of the VCC is still 7.5 volts. The V in is 15 volts. The V out is 0.000362955. I think I should simplify this. It should be 3.6 62955 times 10 raised to negative 4. The VC should be 121,021. VB is 0.787104 and the VE is negative 3.6445 times 10 raised to negative 4. There you have it. It seems that we have a small difference in its values. Nonetheless, now the table 5-5 is done. I think I'll remove this. Remove the there. Now that it is done, I'll just save this one. Save as table 5-5. So new schematics again. We'll make another one. Where is it? Wait a minute. I'm looking for the circuit diagram. Here. I forgot to show you the value. I'll show you later the values of the. Now. I'll show you the values of table 5-5 here. So you can see it's right there. And after that, we'll be having table 5-6. Next is we'll create the circuit diagram of table 5-6. We'll make, where is it? Still, I press F2 and for the voltage, C for the capacitor, Control R for its rotating. Another is the resistor. Zoom out. Resistor here again. Another one here. Another one here. One here. And down, down, down. There. It's just repetitive. This experiment is repetitive. So we'll connect the NPN, F2 and NPN. We'll connect the capacitor. This is the transistor. So connect the wires first. You can see the visualize it. Connect here, down here, connect down here. Oops, it's too long. Forgot to make a node here. There's a node. Another one is the capacitor right here. And another is the R6. Make this way. It's too long. This is simulated values, but and the wires here, even though it's long, it doesn't put any wasted current. But in real life, in actual, if you use long wires, the more the wires, the long current loss or voltage loss it has. So, but this, since this is simulated, there are no current loss or voltage loss in here. Voltage. Connect. Oops. Connect this. Oh, it's too long. Oops. There. I think it's done. Just check. It says here that I should reconnect the output coupling capacitor C3 to the load resistor R6. You know, as you can see, it's already connected. and remove the connection between the bypass capacitor C2 and the transmitter Q1. So in here, C2, I'll just cut this and make it a short circuit. So as you can see, this new circuit diagram is for no, I think it's a no bypass, but it has as a load. So it's a load and no bypass. So this is called a common base emitter with load and no bypass. So we'll put on the value, no, we'll change their names first, VN. This one is VCC. We'll put a label net here of V out. I think it's there. Oops. V out here. Still recording. And change the values, the same one as the last time. There's no C2, so this one is 300 U microfarads. This is 1K, 1.25K, 1.5K. There's no K. I forgot to put the K here. Here's a 2K. Here's a 2.25K. And we'll put 7.5 volts here. I think everything has their values now. So we'll put edit simulation command, simulate, OP, operate, and run. I'll show you the details. I forgot. I forgot the V in with 15 voltage and the label net for VB, VC, and VE for the nodes. Click here, run. I'll show you the values. I'm just put it in my window capture. There, as you can see there, there are the values. So I'm putting in my table. VCC has a value of 7.5 volts and V in is 15 volts. VC has a value of 2.259032. VB has a value of 0.845684 volts. VE has a value of negative 0.1, I think it's negative 1.11037 times 10 raised to negative 4. And the V out has a value of, with the same with VE, negative 1.11037 times 10 raised to negative 4. I think that's done. So now, I think I might repeat this table 5-4. Let me save this first as table 5-6. I think I repeat this table 5-4 with a value. What is its value? Wait, this way. Oh, it's the same. There's a little tweaking here. Let me just show you this. Windows may capture. There. As you can see here, there's a little tweaking from the past one. So I need just to tweak the VC. Well, I didn't see the options of the command last time because I didn't saw that the voltage is in sine wave. But now as it's in DC wave and it has a little tweaking of the voltages, when VB Last time it's 0.787436. Now it's 0.787499. There's a bit of difference from a sine wave with a 15 voltage than a DC voltage of 15 voltage. Negative 3.3. The VE here is negative 3.33065 times 10 raised to negative 5. But with the voltage of DC voltage, it's only 3.0605 times 10 raised to negative 5. The voltage output is the same. I think it's done. So let me show you these 4 tables with their values here. Table 5-4, 5-5, and 5-6. In 5-7, I'll just input these values of 5-4 to 5-6. Just wait, okay? I'll show you it. VC is 7.5 volts. VC is 1.21061 volts. So here, so you can see these are the values of the 3 tables from 5-5 to 5-6. The values of the VCC, VC, VB, VE, VIN and VOut when it is loaded and bypass, unloaded and bypass, and loaded and unbypass. So I think that ends our experiment. I hope you learned something from these 3 tables that I did, and thank you for watching. My name is Dale V. Calizar, again, from ECE20L-2 for Sir Leonardo Valiente. Thank you for watching.